Alright, so in this video we're going to talk about the external distance and the middle ordinate. These are two more parameters we can use when we're designing horizontal curves. So if we had this curve and it was doing its curvy thing, and remember on this curve where the curve starts, this is the BC and this is the EC, this is EC, this is BC. BC stands for beginning of curve and EC stands for end of curve, right? At these points we can draw tangent lines to that point, right? So if you draw these tangent lines, and the place where these tangent lines intersect is called the point of intersection, right? And if we drew lines that are perpendicular to these tangent lines at the BC and the EC, you notice that they are very poorly drawn, but they intersect here at the origin of this curve. And remember, this curve is nothing but a circle. Okay? And we know that this angle is called delta. And we also discovered that the distance from the BC to the EC, or this distance right here, that's called the long chord. It's the straight distance from the beginning of curve to the end of curve. Now, the middle ordinate is actually the distance, so it's the distance from the long chord to the curve. So if we drew, let me draw another line that starts at the PI and goes to the origin, and pretend this is all symmetrical. My drawings are just really bad. That means if this was symmetrical, this would be delta over 2, and this angle would be delta over 2, right? So the middle ordinate is the distance from the long chord to the curve, right? So this distance right here, that's what's called the middle ordinate. And how do we figure out what the middle ordinate is? Well, we can use geometry. So let me draw, I'm going to redraw this segment here. So from the BC along the curve up to this point, then down to the origin, then back to the BC. Okay? So the first distance would be here, right? This distance, and then we have up to the BC, and then let me draw the curve in red, right? And the long chord, which is this green distance, that's this distance right here, right? And we said this was delta over 2, right? So the middle ordinate is this distance, the curve to the long chord, the curve to the long chord. So this distance right here is called the middle ordinate. Okay? And we know that this, if it draws, this is called the radius, the distance from the origin to the curve, distance from the origin to the curve. So all of this is really r. Okay? And if I said that this distance right here, the point where the long chord meets the radius to the origin, that's called r minus m, right? Because radius is this distance up to this distance. Okay? So if I said, okay, the cosine of this angle delta over 2, that's equal to the adjacent side over the hypotenuse, right? So the adjacent side, which is this side right here, right? Ooh, it's from here to here. So that's the adjacent side. Well, if we know this distance is r, from the origin all the way up to the curve is r, and the middle ordinate is this little distance, we can say that from here to here is r minus m, and that's the adjacent side, right? R minus m. And the hypotenuse is r, right? Remember, we're doing this for this triangle right here. Okay? So this formula right here we can use to find the middle ordinate, or this distance, knowing the interior angle and the radius, right? And then the last distance, which is the external distance. The external distance starts from the curve, so it starts where m ends. So it starts from the curve and goes up to the point of intersection. So this distance This is the external distance. Okay, so how do we figure that out? Well, we're going to use trigonometry. We're going to redraw this triangle right here. Okay, so it starts at the PI, goes all the way to the origin, goes to the BC, and comes back up to the PI, right? Remember, this distance from the BC to the PI is tangent. That's a T. So if I drew, let's see if I can draw this by hand. If I drew this, right? It's not that bad. This is the radius, right? And the curve is doing something like this, right? So what I just drew here was this curve here plus this whole side of this triangle is the origin to the PI. So this is up here is actually the PI, and here is the origin, right? And we know that this distance is R, right? We also know that this distance is R, right? The radius follows the curve, okay? The external distance, which is the curve to the PI, or on this diagram, the curve to the PI, so this little distance, it's called the external distance. So how do we figure that out? Well, somewhat similar to the same way we figured out the formula for the middle ordinate. Here we know that this angle is delta over 2, and there's a couple different ways we can figure this out. First, we can use cosine. This is a triangle, so we can use cosine of this angle delta over 2 is the adjacent side, which is in this case R, right, over the hypotenuse. And the hypotenuse for this triangle is the distance. It goes from the origin to the PI, so it's R plus E. R plus E. Okay, so this is one formula you can use to figure out what the external distance is, knowing the interior angle and the radius, right? And the second formula, again, sine of delta over 2. This side we're using the opposite side, and remember, this side, the distance from here to here is t, right? This is tangent. This is the BC, the beginning of curve. This is the point of intersection. So on this big diagram, we know that t is from BC to PI, right? So back to this drawing, we can say that the sine of this angle is opposite over hypotenuse, right? So it's t opposite side over the hypotenuse, which is also R plus E. So if you know, really you only need two variables to figure out M and E. If you know the interior angle delta and you know the radius of the curve R, you can use those two values to figure out what the external distance is and the middle ordinate is. Alright?